Clock is running. Well, thank you for coming to the Hadoop as a Service for Lifecycle Management Simplicity talk way in the afternoon on the second day of Hadoop Summit. My name is Andrew Nelson, and I'm a staff systems engineer for VMware. And I'm kind of unique at VMware because I spend a lot of my time doing different things like virtualizing Hadoop clusters, which is something that not a lot of people talk about, but something I enjoy very much. And also virtualizing other next-gen applications. I work with UCSF in the Bay Area on doing genome sequencing and cancer research, all on virtual platform. Now we're going to be going through some of the operational and technical benefits of Hadoop as a service and talking about some of the architecture and use cases, as well as showing you some of the end-to-end integration and the hybrid data model that's available, again, when we're using virtualization on Hadoop. And with that, I'm going to hand it over to my other speaker, Chris Mutchler from Adobe.
Hi, I'm Chris Mutchler. I'm a compute platform engineer for our digital marketing business unit, so the side of the business for Adobe that handles all of our analytics. We have an operations organization that I handle the infrastructure for, and a lot of that is virtualized on VMware. And as we started to get more and more questions last year about how they could run Hadoop within our infrastructure, we started to look at how best to do that. And as we did, we saw that there was a unique opportunity for us to offer a virtualized Hadoop offering for our business, and to do it using the VMware big data extensions. Oh yeah, here we go. So there were a few things that we started to encounter. We have a fairly large pre-production environment that has, on average, about 3,000 VMs running in it. Depending on the release cycle of any of our products, that spikes up to 4,000 to 5,000 VMs. And in this environment, we started to find that engineering teams were starting to just put Hadoop out there. And so we started seeing these crazy workloads going on in our environment and having to figure out what was going on. And so this is the shadow IT problem that I think a lot of IT organizations face. Engineers have access to an environment, and so they start doing what they want to do in it. And then you, as an operations staff, have to figure out how best to handle that and still give them the offerings that they're looking for. The other big thing is Adobe's a big data company. We should be using Hadoop. Our products right now are using it in various places, but there's no real single view for HDFS. We're managing somewhere around 40 petabytes, 35 to 40 petabytes of data across our various data centers. And the products are getting more and more mature, and they want to be able to offer better insight to our customers. And the other thing that got me excited about this is it's bleeding edge. Nobody really talks about the operations side of how you're going to run Hadoop. Everybody just assumes you have this big pile of hardware sitting somewhere, that when you have a new container that needs to run something for Yarn, that suddenly you're just going to be able to spin up additional compute resources. That's not always the case, and it's certainly not been the case for Adobe. We're a publicly traded company, right? I have to do capacity planning 3-6 months out so that I can order the hardware so that it lands in the data centers. But engineering teams, they want to move a lot faster than that. They want to be able to say to their product counterparts in IT, look, I have this new feature. It needs this new infrastructure behind it, and I need it in 2 weeks. Can you give that to me? And before we started doing more and more virtualization, that wasn't possible for us. We wanted to go over some of the benefits. So this is a lot about what we're talking about. Operational simplicity. You want to be able to manage your workload. You want to be able to have a single viewpoint into what's going on in your environment. You need to have it. It needs to be highly available, right? Not just that the servers themselves are online, but also that when you need additional resources, that they're there, easy to be scaled up, and that's where the elasticity comes in. And then for an organization such as ours, multi-tenancy is super important. We have multiple products across the business, and we have to be able to cohabitate with one another across a shared infrastructure. So as we were working on this, we were trying to figure out where it was going to fit for us. We have a fairly large private cloud environment that we run globally. And as we started to look at it, we found that Hadoop would actually fit very well into our stack. And we wanted to be able to have an offering that would be self-service. We didn't want a systems engineer team to have to submit into the infrastructure team, hey, I want this. We wanted it to be self-servicing instead of ticket as a service. And so that's where we laid down the big data extensions to be able to do Hadoop in the virtualized environment. And then on top of that, we laid down the Virtual Cloud Automation Center, or VCAC. And this gave us a lot of flexibility with we can design blueprints for individual products. We can have different sizes for your Hadoop cluster. We can split it up so that your Hadoop cluster is all compute nodes because you're backed by an Isilon storage, or you can do data and compute node separation so that your compute side can scale up and down as needed. And then the other thing for the performance on the bottoms half here, we found that we needed to have a tier 0 flash, inside the blade chassis to be able to have that scratch space necessary for the data sets that you are running your MapReduce jobs off of. And so we were able to stack all of this on top of our private cloud infrastructure, and it's been very successful for us so far. This goes back to a little bit about our use cases. So we have large pre-production where we have a lot of engineering teams just coming to us being like, I don't know what Hadoop is. I want to try and figure out if it has a place for us. And so we wanted to be able to have an opportunity for them to be able to have a platform in their pre-production environment. And then we have our production environment where these tens of petabytes of data exist right now today. And they wanted to be able to figure out how can we start leveraging that instead of using our custom data warehousing. We want to start using HDFS more and more. And turn this over to Andy now for.
Sure. And while this video is running in the background, I just want you to think about some of the other sessions you've seen here at Hadoop Summit, and understand that there will be a lot of layers of different products. And again, that's operational complexity. There hasn't been a single solution that I've seen here where it is just Hadoop, and Hadoop by itself is a little bit disingenuous working with it because there's two distinct workload types. There's MapReduce, there's your compute layer at least, and there's HDFS, which is your storage layer. Now take that a step further. Are you working with Storm? Are you working with Kafka? How are you dealing with streaming data? How are you working with resource management? Just so happens that VMware has been in resource management business for a while. And also, we've been working on products to integrate with the Hadoop stack for a while. It was over 2 years ago we released Project Serengeti, which if you saw the Ambari session or even the Project Sahara session, you'll find look very similar. Serengeti at its base was a CLI and a Hadoop Virtual Manager to give us the elasticity from a CLI perspective. What's going on in the background here is you can actually see with big data extensions is using this through the vSphere web client to spin up a Hadoop cluster. And again, what we want to get to is that end-to-end integration where you're not just standing up Hadoop, you're standing up the stack. You want to be able to integrate with particular distro vendors, and from the beginning, Serengeti has been interoperable with CDH, Hortonworks, MapR, Pivotal, just to name a few. And so here from a Cloudera manager perspective, again, you want to be able to integrate these tools across that stack so that you're standing up the full amount of services for whatever the particular customer wants to be able to build out. And as you're doing this through Vcloud Automation Center, if anyone's heard of that before, this is a product from VMware that does a self-service portal to stand up customized services like Hadoop, like a developer stack, for LAMP, for anything that the IT department wants to offer self-service access and blueprinting, templating to whatever their end customers are. In the Hadoop case, they want to be able to stand up their Hadoop clusters, first of all, without the developer having to be tied to a specific cluster. They should be able to get these resources on demand. And again, dealing with different resources, dealing with different workloads, different types of workloads, and all of those pieces that need to be brought together to actually build out their solution and experiment with is something that the developers want in order to get their flexibility, their experimentation, they want to be able to play around with these environments as well as recommit them back into production. So everything you've been seeing here is the orchestration that we're bringing to the table to automate this deployment and make it self-service, again, through a couple of different products on the VMware side, as well as touching some of the Cloud Air Manager, for example, or other products, other management distros that are part of that end user experience and working with a Hadoop cluster. And here, at the end, without any having to work with a particular blueprint, at that point, all of those resources underneath, whether it's a Hadoop 1.0, a 2.0 cluster, has fully been provisioned and is accessible to that developer to start working with from their perspective. Okay.
So as we got more and more into this and we started to develop this platform for Hadoop as a service, and we started talking to our engineering teams, there were two big questions that we had to answer for them. Where's my data, and how do I access it? And in a production environment, it's difficult, right? Because do you want to let an engineering team in pre-production have access to production data? Sometimes yes, right? Because if you're doing workload management and trying to figure out what things are going to actually look like, we needed to be able to offer them a segregated environment for them to have access to this. And these are questions that every time an engineering team comes to us and says, I need Hadoop, well, that's great. Tell me, what do you actually need, and help me answer these two questions for you. So this ended up being our solution. So we have this elastic compute layer that allows us to scale up and down using BDE, the big data extensions. Our customers are all internal, and they have the opportunity to choose for themselves how best they want to do it. If they want to stick with a traditional Hadoop model where data and compute nodes are tied to one another, we can do that through BDE. Or if they want to get a little more advanced, we can separate out their data nodes from their compute nodes, because a lot of our engineering teams find that while their data, the actual amount of data that they store month to month, grows at a small rate, the jobs that they're starting to run against that data are becoming more and more complex, and they're trying to get those jobs done more quickly. So we're able to scale out their compute layer for them so that they can more dynamically respond to their needs. And then the big thing for us has been the service blueprints in VCAC, being able to offer a self-service option for our customers to be able to come in and just say, I need this in this data center, and it needs to have access to this Isilon array or this just sandbag storage where I'm going to start sending data to. So we kind of went kind of quick.
And so some of the assumptions around virtualizing Hadoop are typically is that it's only good enough for test dev. But I think some of the other assumptions in there is that a production Hadoop workload should be fairly static, or just that by static you should use up 100% of that hardware. And if you think of utilization, it doesn't necessarily mean that you're being efficient with your queries. I can write a very simple Hadoop job and allow it to use 100% of a Hadoop cluster, and you can expand that cluster and I can use 100% of that. And over again, I can just ask for more resources without being efficient about how I'm actually going about and doing the work. The level of maturity needs to improve for actually working with Hadoop clusters and in these very complex distributed systems. I've seen other sessions here where they talk about the data ingest actually outgrowing their ingest capacity, or if they have a decent ingest rate, that their MapReduce jobs or maybe some of their other normalization jobs for their data sets actually don't complete on time, and then they're back to the same old SQL approaches, not being able to keep up with the data and having to deal with stale data. All of those approaches, again, that's where elasticity comes in. If you buy a physical Hadoop cluster, that's exactly what you're stuck with. That your sizing discussion already happened, you've already bought those nodes, and all you can do is buy more nodes and keep throwing more nodes at the problem, versus actually looking at those workloads, and not discounting the dev test part, because that's where the experimentation happens. That's where more optimization can actually happen on the workload so that you're being more efficient and actually dealing with spikes in traffic in production by getting better at working with the system. Again, we talk about some of these Hadoop systems. These are, again, multi-layered with Storm, with streaming data, with batch data, with SQL and real-time queries coming into the system. All of these different components may have different workloads depending on the number of jobs thrown at them, whether they're scheduled or interactive, and trying to deal with those requirements in a production system requires that elasticity that allows, or that depends on the different layers being able to scale independently if you actually want to get queries done on time. Again, if you're just dealing with a pure batch system, then it's kind of dumb. You just wait for stuff to finish, and if there's something that's taking up 100% utilization, then you're just waiting for that to be done. You can either kill the job or wait for more things to come into the pipeline. And the more complexity you add in equals more possible bottlenecks where everything needs to be tuned and responded to appropriately. Otherwise, your overall performance is going to suffer. I believe it was the Hulu talk where they talk about their data pipeline, and making sure that you are efficient at each part of that data pipeline is key to actually leveraging Hadoop and all of that data they collect for their enterprise applications.
So I'd like to open it up for questions. Please.
Yeah, I have a couple of questions. The first one is on the big data extensions.
Mm-hmm.
So on the video, I didn't follow it, but it looks like you can use that to basically build up your nodes. And then you went into basically the Cloudera manager.
Mm-hmm.
Is that a built-in plugin for to actually set up Hadoop itself going into the
Right, so basically, and you'll see this with other client blueprints, template. So Big Data Extensions has a vApp, which is basically a management server and a template node. The management server, I guess, is the client providing the GUI and access. Your template node is what's going to be laid out across your infrastructure. Serengeti would do this through CLI, and Big Data Extensions is just the GUI so that you can pick out the sizing of your nodes and pick your template. Again, it's going to be based on some distribution, some Hadoop distribution, some set of packages that you want laid out across all of those worker nodes in your environment. And then once you pick the size of that, it's going to actually go and clone that out to all the individual nodes, do the resource assignments. Again, the resource assignments are basically being pulled from a JSON file defined by what you're doing in BDE or Serengeti, so that you can actually keep that as your blueprint, lay out your Hadoop cluster, change it, change the number of nodes, interact with that dynamically to what your actual big data environment is going to look like.
So what you saw in the video there was actually BDE just laying down blank VMs with an operating system, but no actual Hadoop distribution applied onto it. And so what it was doing was just showing the orchestration, that it was then opening things up into Cloudera Manager, so you can go back to if you're a Cloudera person, what you're familiar using Cloudera Manager for, and then it was laying down the Cloudera software on those blank VMs that the Big Data Extensions created for you in the background. So there's a lot of orchestration that you can do with both BDE and the service blueprints through VCAC. And that's where you can work with your individual engineering teams to find out what their needs are, and then you can tailor a service catalog blueprint just to an engineering team, or you can have a generic infrastructure offering that anybody can just go and self-serve, right? Because every Hadoop workload is different, right? Every product that I have to support has a different workload profile. So what works for one is not necessarily going to work for another, but using BDE, they can coexist on the same shared infrastructure underneath.
So if you already have VMware, you can just download BDE.
Yes.
Yep.
You can go to vmware.com/Hadoop, and it's right there. Any other questions? Yes?
Which version of Cloudera do you use?
4.5.
4.5.
Yes.
I understand HPE helps the locality, data locality for virtualization, and from what I know, Cloudera does not support the HPE.
So Cloudera, right, the HVE extensions, the Hadoop virtualized extensions aren't supported by Cloudera, but they are by the Apache distribution, which is included in BDE, and you can also use PhD, the Pivotal supports it as well, and some of the others
Okay.
as well.
When you used Cloudera, how did you manage the data locality issue? When more than one VM is on the same physical host, how did you make sure the number of replicas are?
So I just set up affinity rules within VMware to make sure that certain data nodes were in certain LUNs that were assigned back to our SAN storage. That's one way you can do it. The other way is you can actually have Isilon. If you're just exporting HDFS off your Isilon, it'll be your name node, and it'll handle the data locality on the back end. So you wouldn't necessarily have to have Cloudera support it because your Isilon is doing it for you on the back end.
If we have a choice of not using Isilon, just like the
Yeah.
bare metal machine, then the affinity rules can.
Yeah, it can help you with that. And you can set all that up in your JSON files.
Okay. So what does it do? Like that way you're not putting more than one.
Right, it's going to pay attention to where each node is in your virtual infrastructure. So,
On the top of it, I think even the scheduling the jobs, how is it taken care of? I think that is another part which HPE takes care of.
yep, so it just sets all of the components up for each node so that it knows where the task trackers are in the job schedulers. Do you want to talk more about the HPE?
Another nice thing about Isilon is for ingest. So it's a dual use file system. Basically, you can write the files to the Isilon as whatever that file system mount is, and then retrieve it as a HDFS object from any of the data nodes.
Exist.
Yep.
Yeah, so we pay close attention. So we work very well with our network engineering team and our storage team to make sure that our Isilon storage and our compute infrastructure are next to each other, so it's all L2 traffic, so we don't have to worry about routing between it, so we get the best performance between the two pieces, so that everything ties together nicely.
Another quick question. Like,
Sure.
Sure.
Do you have any reference structure or anything like what could be like how many VMs apart the physical server, some kind of a
So right now, we've been basing it off of 1 VM per physical core.
one VM?
Per physical core, and that seems to be scaling well, depending on the jobs that the engineers are writing for MapReduce.
Per socket or per core?
Per socket, sorry.
Per socket, yep.
So did we enable the hyper-threading in those
Yes.
fields that's recommended versus do you do any characteristics?
Say the last part again, I'm sorry.
So did you guys try with and without hyper-threading enabled?
We have it enabled by default in our infrastructure. So
So another question, like if you have Isilon in place, how do you size your VMDKs? The local, so in BDE you have a drop-down menu where medium, large, like by default picks some 100 gig for large. So it's all some number. You can, what is the logic behind it?
So that scratch space that we're using there, that usually goes back to our HUSVM by Hitachi. So our VMDKs are living there, and then it just has an HDFS export off the Isilon that it's working against. So the scratch space is what gets written up into the VMDKs on the HUS VMs, and then that's where that tier 0 flash layer helps. So we have physical SSD drives in each blade in our infrastructure that acts as a flash acceleration.
Yep, and that is read and write cache.
Read and write cache.
So how big are those?
Depends on the cluster, and that's where the customization comes in, right? We have some, in a pre-prod environment, they don't need a lot of space because maybe they're just trying to figure out how can I write a MapReduce job that would run against this very small subset of data that I've taken out of production, right? So we can give them a very small environment. But then, an actual production node might need, a full terabyte on each one, and we customize that to each one of our customers in the service blueprints, which are then just a single click away for them to be able to provision out into production.
Once the cluster is created, will I be able to add more storage to it by some workflow?
Yep. So through BDE, you can increase the size of the nodes, so you have elasticity there. So you can increase the data nodes, you can increase the compute nodes, and then you can also scale out. So you can say, well, my compute nodes, I don't necessarily need more of them, but maybe I just need more CPU resources or more memory resources assigned to them. So you can do that as well.
How about storage?
Generally, we've been doing like 40 gigabytes per compute node. So, but yeah, and then one of the other things that we're starting to look at is we're doing resource modeling, and this isn't yet implemented, but we're looking at being able to, instead of retroactively increasing a cluster's size, to be able to do anomaly detection on the workload so that when it's peaking, we can just spin up additional resources automatically without a systems administrator or an engineer having to go to the cluster and say, okay, now I suddenly need more resources because it's Cyber Monday and I didn't anticipate correctly for what I was going to have to do for my retailers.
How big are your virtual clusters?
So it depends on the product. We have one that's 400 nodes right now that we're working on, and then we have some others. It really just depends on the product.
And all like virtualizing clusters are you using in production too?
I'm sorry?
In production?
Yes, in production.
Thanks.
You're welcome. Any other questions? I think we're a few minutes early.
All righty. Well, you get a few minutes back.
Okay. Thank you
Thank
so
you
much
very
for
much.
being here.